314 binary tree vertical order traversal. So for this problem, we are given a binary tree, and we want to return the vertical order traversal of its node values. So i.e. from the top left, from top to bottom, column by column. So yeah, let's just check the first example. So this is from top to bottom. First one gonna be 9, and then it's gonna be 3 and 15, and then it's gonna be 20, and the last one is gonna be 7. So this is just the vertical traversal. Yeah. But if we are giving a random binary tree, our traversal is always like the root node, and then go to the left and go to the right, and then go to its left and its right. So this is no matter if it is a DFS or BFS, definitely, yeah, this is the traversal of the binary tree. But our problem is that we need to get the vertical order traversal. How can we do that? Actually, we cannot. But we can use some data structures to store the value, and finally we can give the output of this value. Even though we are using the level order traversal, I mean level by level, we're going to use the BFS. But we're going to store all the values as a vertical index. So for example, from the beginning, this in we're going to set this k going to be 0. We're going to set it as a level 0, and this one we're going to set it as a -1, and this one is also 0, and this one is a +1, and this one is a +2. So actually all those values are going to be the k of the dictionary, and the value going to be all those nodes. So for example, for this k0, it's going to store a node of 3 and 15. So this means we just need to return all those values, and then this is going to be the final result. Yeah. Now let's just try to solve it. So if not root, we're going to return an empty array. Now we have the root, so we're going to use the BFS. So we're going to prepare a queue. It's going to be a big queue, and inside it's going to be the root node and with a level. So this level we're going to set it as 0. So for the root node, the level going to be 0. Then we're going to use the BFS. So while queue, we're going to pop out the node and with a level. So it's going to be equal to q.pop left. Yeah. Now what are we going to do? We're going to check the left side and the right side. So if node dot left, yeah. So we need to append the value right. Yeah. So the value gonna be, yeah, node dot yeah, so it's gonna be a tuple. Inside it's gonna be node dot left, and if it goes to the left side, so what's gonna be the level? So it's gonna be level -1. And similarly, we're gonna check the node dot right. Yeah, and let me just copy the code. So here gonna be node dot right, and if we want to go to the right side for the vertical level, definitely this level gonna +1. Yeah. Finally, yeah, I didn't prepare the dictionary. Let me just prepare a dictionary. It's gonna be a default dict and with a list. Yeah. Now I pop out this value and I want to put it inside of the dictionary. So it's gonna be d level dot append with this value, so the node dot value. Yeah. So finally, we just need to return the dictionary. So it's gonna be d with k. So for k in sorted d dot case. Yeah. Yeah, because we need to return the value in increasing order, basically from left to right, top to bottom. This is according to the description. So we need to sort the case. So basically for this example, it's going to be -1, 0, 1, and 2. Yeah. Now let me just run it to check if it works. As you can see, it works. Now let me just submit it to check. Now as you can see, it's pretty fast and it's part of testing cases, and the time complexity is O(n). N is the number of the nodes. So the node are going to be 100. I think that's all about it. Thank you for watching. See you next time.